All right, some linear modeling skills practice. You're bored on a Friday night, so you and your friends head out to the local dive bar. They have a live band, and they're advertising a $5 cover, 250 drafts. So using X as the number of drinks you buy and Y as your total cost, construct a linear model. Okay, so think about in terms of a linear model and what that means. So Y equals slope. Slope is the thing that changes consistently. And in this case, if you look at your numbers, if you pay a $5 cover, you pay that one time. And that's it. One time fixed fee. 250 draft, that's every time you buy a drink, right? 250, 250. So there's your constant change, because every time you buy a drink, and drink is the X, plus your $5 cover. So this is your linear model to represent how much you're going to spend that night. Now, what is the slope? Well, as we just said, the slope is 250 because that is what's constantly changing. The y-intercept is 5, right? The cover charge, because that's your one-time fee. If you drink 3 beers, how much will you spend? Okay, well, our model is here. Well, 3 beers is the number of drafts. So 2.5 times 3 plus 5. That's 750 plus 5. $12.50 is how much you will spend if you have 3 beers. All right, you got a $20 bill in your pocket. Okay, again, here's my model. I have a $20 bill. How many beers can you buy? Well, that means your total you can spend would be 20, right? That's your Y. So we've got to say, okay, we need to get X by itself. So first we would subtract 5 from both sides, because you got to pay your cover charge first. So you've got 15 beers, or $15 left to buy beers, right, at 250 piece. Or you be the DD and then you drink water or pop for free. That's the way to do it. 15 divided by 250, you can drink 6 beers for $20. Let's move to 15. According to the National Highway Traffic Safety Administration, there are 2,116 motorcycle deaths in 1997. This number grew to 5,154 in 2007, according to the same data. Assuming the number of deaths in that 10-year period was linear, calculate the slope and explain its meaning. Okay, if all we're doing is finding the slope, well, we need ordered pairs. So time is usually, because it depends on time. The number of motorcycle deaths depends on what year it was. So we would say in 1997, there were 2,116. In 2007, there were 5,154. So when we're finding our slope, y2 minus y1 over x2 minus x1. When I do that, I end up with 3,038 over 10, which is approximately 303.8 over 1. So what does that mean? Well, remember the top is motorcycle deaths, and on the bottom we're talking about years. So the meaning is that there are approximately 303.8 more motorcycle deaths every year in compared to the previous year, right? It increases 303.8 deaths every year. That's a lot. It's almost one a day. That's just a lot. Let's go to 16. Michael is a teacher who would like to take the summer off rather than finding a summer job. He deposits his $2,700 tax refund into an account and deducts his expenses each month from that account. Michael estimates his monthly expenses for food, rent, and utilities are $950. Create a linear model representing the amount of money in his account at any given time. All right, so the way I see this, Y is the amount left in his account. He spends $950 a month. So X is the number of months, 950 is the money going out. That's why it's negative, right? It's going down. His account's going down by $950 every month, but he starts with a positive $2,700. Okay? So, in letter B, how many months will he be able to live off his refund? Well, basically, so if we're at Y equals negative 950X plus 2,700, living off his refund means, he'll have 0 left. How many months can he go before he's out of money? So again, right, we're going to solve. So we first subtract 2,700 from each side. That gives me negative 2,700 equals negative 950x. We'll divide both sides by negative 950 because that's the number in front of x. And we get 2.84. He can live 2 full months and then a partial. So either he just can't eat that last month. I mean, you can pay rent. You got to pay rent. You're going to get evicted. So pay rent and then just not eat, maybe. But basically, will he make it through the 3-month break? Only if he doesn't eat. right? He's got to cut expenses somewhere. At $9.50 a month, he cannot make it. Sorry, buddy. Number 17, the state of Indiana has set a goal of 60% degree attainment among adult Hoosiers by the year 2025. If the percent with degrees was 33.2 in 2010, construct a model to estimate the goal for each year. Okay, so let's think about this. Let's call x equals 0 for 2010. All right, so that means 0, 33.2. Oops, that's a decimal point. That's 2010. Now 2025 is 15 years later, so that would be x is 15. So 15, we want it to be 60. So to find our slope, y2 minus y1 over x2 minus x1. So I'm going to change this to a decimal, and I get 1.787. This is my slope. That means I need the percent of adults with degrees to go up basically 1.8% every year. That's a pretty large jump. You got to make some magic happen there. And now, where's our y-intercept? Well, when x is 0, so we know our y-intercept is 33.2. So my model, we're going to do this in burgundy, y equals slope, which I'm going to go ahead and write as a decimal, plus my y-intercept of 33.2. According to the Lumina Foundation, okay, wait, let me give you my model before I even read that question. So according to the Lumina Foundation, the number of Indiana residents with 2-year degrees on or higher had risen to 34.7 in 2013. That's good. How does this compare to the value predicted? So if our model, has kept up, how does that compare to what it should be? Right? Because our model talks about what things should be. So in 2013, remember that x equals 0 for 2010. So 2013 means x is 3. Okay, so when I go to my model, I plug in 3 for x, and I solve. So I multiply these pieces first, and I get a number. I didn't calculate, but after I get that, then I add 33.2, and I end up with 38.561. This is my final answer. So if we had increased at the rate we were supposed to, in 2013, we should have been at 38.561. We were only at 34.7. So we're behind. Even though we increased, which is good, that's positive, that we've got to celebrate that increase, we are not on pace to make our goal based off of this model. So we need to pick up the pace. Number 18. Speed E Pizza has opened a new store near campus. The pizza boxes for opening night have not arrived, so the manager Cheney borrows 75 boxes from the location across town. When the boxes are delivered, Cheney plans to have Peppa fold boxes in addition to her other duties before delivering the 75 boxes to the store on her way home. She can fold 15 boxes per hour between her normal tasks. Now, I'm sorry, but I think this question is very, very confusing, so I'm going to do my best to kind of explain it. Using X as the number of hours Peppa works and Y as the number of boxes, construct a model represent the number of boxes that belong to Cheney's store. Well, okay, so Peppa can fold 15 boxes an hour. X is the number of hours, but they're giving away 75 boxes across town. Wait, they're borrowing 75 boxes, so maybe that's above. Time out, I got to rethink this horribly worded question. All right, I'm going with this. I still think this is right because the 75 boxes have to go, because this is what gets me. She delivers the 75 boxes to the other store, which means you take them away, right? So if she's taken away 75 boxes, we're trying to figure out the number that belonged to the store, and you got to get rid of those 75. This is what I'm going with. So we've got this model. If Peppa works a 10-hour shift before delivering the boxes, how many boxes will Cheney have on hand to start the next day? Right? Because she's delivering the boxes. So if she works 10 hours, she can make 150 boxes, but then 75 are going to the other store. So Cheney will have 75 to start the next day. I think that makes sense because she's delivering. This question makes me want to vomit because it just doesn't make any damn sense. So I don't know. If that's wrong, if somebody watches this and that's wrong, will you please tell me? Because I don't understand what the hell they're talking about. All right, let's go to the next one. Something that actually makes sense. According to the World Health Organization website, WHO, the number of measles deaths in 1980 was estimated to be 2.6 million. In 2013, that number had decreased to 145,700 people. Did you know that people still died from the measles? I did not know that, but it is true. It happens. Assuming that decrease was linear, construct the model. Okay, so we got to think, when are we starting? We're starting in 1980. So in 1980, we're saying that x is 0. So our ordered pair would be 0, 2.6 million. What the heck happened? 2.6 million. Right? And I wrote that in standard form because this number here is in standard form. 2013 is 33 years later. So my ordered pair would be 33, 145,700. So when I do this and I change this, okay, so now we do change in y. Oops. 145,700 minus 2.6 million divided by 33 minus 0. Now, in the numerator, we get negative 2,454,300 over 33. And, you know, this is difficult because you're thinking, well, that's a slope? Right now, we can divide that number by 33. We get negative 74,000. And maybe that's the way to do it, right? So our model, we're going to go ahead and write this as a decimal. We've got y equals negative 74,372.73x, and then my y-intercept, which is plus, I need all my zeros because I'm in standard form. And at this point, you're thinking, wow, that's really big. And it is. Now, we could have done, this is 2.6 million, this is 0.1457 million, and you could have done it in terms of million, but I know how people like to do that, so standard form is fine. So we have ourselves a number here. So write a sentence interpreting the slope. Well, the slope was negative 74,372.73, and I made it a decimal, so it's over 1. Now, this is measles deaths, and this is per year. So after 1980, so measles deaths decrease. I know it's a decrease because I have a negative here. They decrease 74,372.73 per year after 1980. You got to have that 1980 in there because that tells you when you started, right? So you got to have that in there. All right, the next one. Death Valley, California has an elevation of 282 feet below sea level. We're starting at negative 282, my friends. Amy starts digging a hole. I don't know why, but she digs a hole, and she's digging down 1.5 feet per hour. Construct a linear model representing the depth of her hole. Now, I'm going to take this into account, depth by sea level, because if not, this is kind of a dumb question if you're not considering sea level. So Amy, she digs down 1.5. Now, I put a negative because she's going down. It's getting deeper. Negative 1.5x minus 282. All right, she's getting further down. She's starting at negative 282 because she's in Death Valley, and then she's digging down another negative 1.5. Now, Sarah is taking the dirt that she digs, and she's piling it up at the same rate, which is 1.5 feet per hour. So Sarah is adding 1.5 feet. It's going higher, but she is still starting at negative 282 feet below sea level because she's in Death Valley. So, letter C, after 3 hours, what is the difference between the height of Sarah's pile and the height of Amy's, and the depths of Amy's hole? Well, if we're talking about Sarah, Sarah's got 1.5 times 3 minus 282. Her pile is now at negative 277.5 feet below sea level. And Amy, negative 1.5 times 3 minus 282. Her hole is now 286.5 feet below sea level. So if you check out the difference between these two, there's a 9-foot difference. And that makes sense. After 3 hours, Amy has gone down 4.5 feet. Sarah has piled up 4.5 feet. And 4.5 and 4.5 would give you 9. So you really could think through that without actually doing any math. Well, math with equations, but whatever. There you go. That's it.